The average home uses 10% of its electrical use in refrigeration, your refrigerator and your freezer. In the winter in Alaska, when it's so cold outside, it doesn't necessarily make sense to do this. So what we tried to do was use the cold temperatures outside to keep the refrigerator and the freezer inside cold. Thermal siphon is a way to passively move heat from one place that's warmer to a place that's colder. Our thermal siphon is simply a tube in the back of the refrigerator that has refrigerant in it. When we put something warm in the refrigerator, the refrigerant in the tube in the back of the unit evaporates from the heat that we just put into the refrigerator, and the gas rises to the top of the thermal siphon, which is outside in a colder spot. And when it hits the cold outside air, the refrigerant condenses and flows back to the bottom of the tube, where it can start that cycle over again, continuing to pull heat out of the refrigerator and dissipating it outside.
The fact that we can use what some people consider a problem or a detriment up here, we can use to our advantage. Sub-zero temperatures. Not everyone likes that, but you can take advantage of that with passive refrigeration. It is easy to take heat away from a device, like a refrigerator or freezer for that matter, and eject that heat outside into the sub-zero.
People were saying, well, why don't we just put an open pipe to the outside and just pipe in cold air? The problem with cold air in Fairbanks is it's too dry. Everything in your freezer will get really desiccated in the dry air. The problem with a refrigerator in the dry, cold air is it's not controllable, and everything in the refrigerator will just freeze. So the thermal siphon's a really nice option if you don't want to freeze your refrigerator solid. Trans-Alaska Pipeline has thermal siphons, and they're used to keep the ground cool so that the permafrost doesn't melt and the pipeline doesn't get out of whack. They're also used in roads. Thompson Drive over here at UAF has thermal siphons in the roads. So when the ground temperature is warmer than the air temperature, the thermal siphons draw the heat out of the ground and release it to the air, and that just creates a colder ground, which in the winter or in the summertime takes longer to thaw. And then the permafrost stays pretty stable that way. In this study, the retrofit, whenever it got below 0 outside, 0 Fahrenheit, the compressor didn't run, so it didn't use any electricity. Whenever it was 0 degrees outside, which is pretty good. The overall for the whole year that we did the study, this retrofit used 16% less electricity.
This may not really be appetizing in lower 48 because their energy costs are so low. It's a little more appetizing up here. We saw the mechanical refrigeration basically not running for 3 months in the dead of winter. Yeah, there was some savings doing it in Fairbanks, but our cost per kilowatt hour is actually very low versus the villages. Theirs could be 3 to 4 times higher than ours, and it could very well make sense installing simple passive refrigeration.
Our thermal siphon has refrigerant in it, which is an EPA-regulated substance, so we had to have a refrigerant technician come and help us build the thermal siphon.
It might seem simple, but you could get hurt, and it's really about the pressures and the refrigerant properties that could hurt you if you're not trained in it. What would need improved is temperature control of the medium temperature compartment. Things can get out of control real fast with passive refrigeration, like out of control too cold. As we refine, piping methods of this, what's the smallest diameter we can go. Different refrigerants too have different properties. Don't get complicated with it. It's a matter of, I want one end of it in one environment and the other end in another. I want to move heat from here to there. It's really that simple.